We're solving problem 21 from AMC 12B from 2022. Let S be the set of circles in the coordinate plane that are tangent to each of the three circles with equations x squared plus y squared is 4, x squared plus y squared is 64, and x minus 5 squared plus y squared is 3. What is the sum of all the areas of all circles in S? So we have these three circles and we can roughly draw them. Our first circle here is the one centered around the origin, the smaller one, who has a radius of 2, which is the x squared plus y squared is 4. Looks about like this. This is not going to be drawn to scale, but it's going to be make do what you have. So if this is 2, that's the midpoints of those parts. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay. This is so basically why I'm making it only 8 total ticks here is the next circle. This x squared plus y squared is 64 has a radius of 8. So 1, 2, 3, 4, 5, 6, 7, 8. I can loosely draw it here. It should be a perfect circle, but alas, it looks like this. And our final circle is it's a circle, but now its x coordinate is and not 0. So this is 1, 2, 3, 4, 5, and it's centered about like so, because its radius is 1.5, or no, the square root of 3. So it's about here. Now, it's asking for, you want to find the area of the number of circles that are tangent to these circles. Now, there could be one way to find one. Well, you can create a circle that's tangent to these two circles, these three circles like that, on the inside of this big one, and the outsides of these two smaller ones. We want to find the area of this circle. Since we know that the big radius is 8, and we know that the smaller one is 2, we know that 2 plus this length has to be equal to the square root of 64, or 8, as the radius of the big circle is 8. That is 6. So the radius of that circle is 3. So R1, let's call it. And how many circles are there? Well, there's one here. There's going to be bound to be another one here. There's going to be a third weird one like this, possibly. Yes, that's true. And then a fourth in that same manner, except it's touching that side. So, what is the area of that circle we just drew? Well, that's 9 pi. There's 4 of them, so this is 36 pi. Now, looking at our answer choices for this problem, we know that it can't be this because all the answer choices are greater. And, well, it's true because there is a second case where if we, erase these circles, there's going to be a larger circle involved if I can just depict it. So that's our one circle. Our other circle is if they're internally tangent to this one and externally tangent, internally tangent to those, externally tangent to that one. This circle has nothing to do with it, but it's going to be tangent to those circles like that, and then it's going to curve around going tangent to that point. Okay. Well, now the radius here is clearly bigger, as it is now a whole different type of circle, right? So what we can do is, we know this is 2. That whole distance to the edge is 8. If you have another, this circle's bound to be bigger. Or no, it's not supposed to be bigger. But the radius is the diameter is 10. So the radius is 5, because this, you have to count, this is 2 and this is 8. 2 plus 8 is 10. So R2 is equal to 5. Since the area of one circle is 25 pi, how many are there? Well, again, there's 4 of them, because there's also one here, and then one there, and then one there. Yeah, vice versa. So times 4, 25 pi times 4 is 100 pi. So when you sum 36 pi and 100 pi, you're going to get your answer of 136 pi for this problem.